In .NET 5, WebAPI has an important quality of life upgrade. In this video, we'll be looking at the integration of OpenAPI into the project, how it works, and then why that's so important. We'll also be looking briefly at NSwag and how to use it to generate API clients for our other applications using that OpenAPI standard. Now, if this is the first video you watched of mine, my name is Tim Corey, and it's my goal to make learning C# easier. I provide videos twice a week here on YouTube to help you grow as a developer. I also have a full set of training courses on IamTimCorey.com. I encourage you to check out all the resources I have to offer. In this video, as with most videos, I'm going to create some source code. If you'd like a copy of my source code, just use the link in the description. You might even get a special bonus just for downloading that source code. So let's start looking at what's different in API in .NET 5. So let's go to create a new project, and we'll look for a not desktop project. Let's go to all project types, and we'll look for a ASP.NET Core web application. Hit next. Let's call this our demo API, and let's call this our demo app. And we'll hit create. And we're going to select an ASP.NET Core web API that's .NET Core and .NET Core 5.0. So that's going to be our new project type. Now, if you notice on the right, no authentication, yes, HTTPS, and there's this new checkbox right down here. It's really small, but it says enable OpenAPI support. And by default, that checkbox is checked. We're going to leave that checked. That's important. So hit create. If you don't see that checkbox, probably you're not on a .NET 5 project. You probably selected .NET Core 3.1. Now, if you have worked with an API project before, especially a .NET Core API project, this will look very, very similar. In fact, if you have taken my course that intros the 5 different types of ASP.NET Core project types, that's the getting started with ASP.NET Core. In that course, we deal with a .NET Core 3.1 web API. We build that out. This will look extremely similar to that. The big difference comes in startup.cs, where we'll see right down here, these lines are extra, these lines are extra, and that's it. That's really the big change when it comes to the code of our API project. So what do these lines do? Well, this is adding what's called swagger gen. Now, if you have seen what we did in the Timco Retail Manager series, if you're not familiar with that series, what we're doing is we're building kind of a real world application to simulate what you'd come into on day one of a job. So you can pick up the middle of a series and it simulates you walking in the front door and say, okay, I just got hired, let's start working the project. And in that project, we've got an API that we hooked up Swagger to. And Swagger it's an open API is what it's called now, but really it's Swagger. And so what Swagger is a way to kind of document your API, but it's more than just a nice visual. We're going to see that in a minute. But let's talk about what's happening here. So let's unpin this so we can see the whole length. We have Swagger Gen, and it says Swagger Doc version 1, and then the title is going to be our demo API, and the version is v1. So this is saying is our API is version 1, and the title of the document for Swagger is going to be our demo API. This right here, and then these lines right down here, that replaces all the configuration we used to have to do. We had a whole configuration page we used to have for Swagger. It was really confusing, had a lot of stuff in it. If you didn't get it quite right, it didn't work. It was kind of messy. Well, now those 3 lines configure our OpenAPI, also known as Swagger, for us. So this is the configuration, the generator configuration. This is the user interface configuration. So for example, the swagger.json file that it creates, there's the path that it will be on. And then the name of that will be our demo API version 1. And I keep saying version 1 because with an API, you really don't want to change your signature. So if you have a GET call that has no parameters and it gets back weather data, you don't want to then all of a sudden change that to require data being passed into it first, because that will break all the clients that were depending on your API. And so what you do is you create a version 2 of your API and say, well, that old call still works, but it's a version 1 call, it's deprecated. Now we have version 2 calls. And you can version your API like that so you don't break old clients, but you can bring new clients on with new functionality. So Swagger supports that. It supports the idea of having multiple versions of your API in the same API. So right now, we're not going to get into how to version APIs. That's a little bit further down the rabbit trail that I want to go. But at the very least, I want you to see the Swagger generator, the Swagger UI. That's all the configuration we have set up. And then just use Swagger. Notice that it's in the is environment for development, is development. This is important because if you're not comfortable having your Swagger code visible for anybody to see, then you only want it in development. Well, it's already set up for that. .NET Core, when it was reimagined from .NET Framework to .NET Core, one of the things that was a big mantra was security first, secure first. Make sure that we lock this thing down and then you can unlock it how you want, but by default, it's going to be locked down. This is one of those things where it's locked down to only do this in development mode, meaning only in our dev servers, only when we're debugging, but not in production. If you want to use it in production, not a problem. You just move these 2 lines outside this if statement, and that will work in production. But you have to make that conscious choice. I really appreciate the standpoint of we're going to be secure, and then you can make it work at whatever level you want it to. Now, that's not saying that it's unsecure to allow this in production. It may be exactly what you want. In fact, we're going to see a use case with our NSwag where we can generate clients and have them work off of this swagger.json file to identify how to build a client. Well, that may be something you want to permit external people to do. In that case, you might want this to be a production-ready thing as well, and that's fine. But right out of the box, we're going to run this application. Now, we're going to see what Swagger brings to the table, but we're also going to see something new. And that is, when I run this application, it's going to launch right to Swagger. So when it launches, notice it goes right to Swagger. It used to be that when you launched an API, it went here. Or maybe it would go here. But typically it would go right to the root, and there's nothing there. And we used to put something there just to have something to display, but now it goes right to Swagger so that we have a landing page we can work from. So that's another update that came about with .NET 5 and the newer versions of Visual Studio, is when you launch the application, it launches to Swagger. Of course, only if you have Swagger installed. But it launches to Swagger, that way you have to dig for it or find it, it goes right to it. Now, if you're not familiar with Swagger, I'll give you the brief overview. And again, Swagger and OpenAPI are interchangeable at this point. So just note that one kind of equals the other. We'll use them interchangeably. There is some nuance there, but we're not going to get into that. So as you can see with Swagger, what it's doing is it's documenting for us what our API looks like. Now, right now, our API only has one controller, weather forecast, and one action inside of that, and that's the get action. That's the only one we have. Now, inside there, notice you can click on that and it expands, and it says, okay, it doesn't take any parameters. The response codes typically are just 200 success. It doesn't document any other types of response codes. And here is the schema down here for what that return would look like. Now down below we have schemas for weather forecast. And again, it shows us, and let's see if we can zoom in here. It shows us what the schema for that returned object would be. A date, a temperature in C, a temperature in F, and a summary. And again, string, 2 integers, and a date time string. So that's one weather forecast object. The weather forecast get command, notice the square brackets here, returns an array of these objects. So that's the whole documentation for the get, but then we have this cool button over here that says try it out. Now, we don't have any authentication in here. Yes, that does add some wrinkles to it. We're not gonna get deep into that. We probably will at some point, not in this video, but in a future video, because authentication has changed as well. There's a lot of really cool new things around authentication in .NET. It's gonna take some time to dig into that and really teach it well. So I'm not gonna teach it in this video, but just know there's no authentication here in this API. But if we hit try it out, it says, okay, there's no parameters, so just execute. When I execute, it says, okay, you got a response code of 200. If you're not familiar with HTTP response codes, a 200 means okay, or everything's good. And then here is the response body, which is that array with all of our weather forecast information. So for this, well, I'm off, there you go. For this date, it's going to be 32 degrees Fahrenheit, which is bracing. This date will be 82 degrees Fahrenheit, which they call chilly. It's not chilly. That's rather warm. 111 is balmy. We need to put our descriptions back in here because this is totally crazy. But that gives us our response right inside of Swagger, inside of Swagger UI, so we can play around with it. Or we can even download it or copy it to clipboard. Now, what does copy to clipboard do for us? Remember that in Visual Studio, let's copy to clipboard. And then in Visual Studio, and let's see if I can do this while it's running. We can come down here and there is a paste special, paste JSON as classes. I can do that and notice it created a root object called property1 for an array of classes. And then class 1 is date, temperature in C, temperature in F, and summary. That looks a lot like our weather object or weather forecast object. And it said, this is the JSON structure expressed in C# code. So that copy allows us to create these objects very quickly in our C# code. Now, of course, it didn't pick intelligent names, but that's kind of up to us. So we can get rid of that. That was just kind of a demo because there's better ways of doing this. And in fact, this application already has those things built in. But this is what Swagger does for us. Swagger gives us all of this great user interface, this great UI to get all this, these calls to try it out, to execute, to clear the contents and execute again. And now we have different values. Really cool stuff here. But it goes even further than that. And this is where I think that OpenAPI/Swagger is such a big deal for putting into an API. And it's something that may get missed in the mix. And that is right underneath the title here, we have this link, swagger/v1/swagger.json. Let's click on that. And there is our JSON. Let's kind of zoom in here a little bit. This is our JSON representation of the Swagger information. This is what the UI is showing us in a pretty format. So why is it important to see this? Because really it's kind of messy, right? But what this does is it allows us to create clients. Let's do this. Let's Let's zoom out here. And we're going to wait on this project. I'm going to wait to save. No, I'm going to save this right now. Let's just save as. And what we're going to do is go back to our Visual Studio project. We'll pin that again. And we're going to open. I think copy full path might have done it for me, but let's make sure by doing that. And then I'm going to paste it right here. So you have a swagger.json. I'm going to put it right into the same project I'm working with. That's just a placeholder for now. But now we have this. Let's close this out. And now in our Solution Explorer, now we have a swagger.json file in our project. We don't actually want it in this project right now. We want it in a different project, but I wanted to save it for now and then create a new project. So let's do that. Let's right click on our solution. We're going to say add new project. We're going to add a Blazor app. And let's call this Blazor WASM demo. WASM stands for Web Assembly. And we'll choose Blazor Web Assembly. We are going to cover the new stuff in Blazor in upcoming videos. So that's coming soon. We're not going to cover it in this video, but just know that the Blazor video is coming with all the new stuff that's in Blazor. Some really cool stuff going on there as well. But let's just use Blazor Web Assembly. Because remember that Blazor Web Assembly needs an API in order to get data. So let's hit create. And now we have a Blazor WebAssembly application. What I'm going to do is I'm going to drag this swagger.json over to the Blazor.WebAssembly project and delete it from our core API. Okay, so now in Blazor WebAssembly, if we right click and say startup project and just run this just to see, what we're going to find is that it already has a simulation of the weather forecast. So fetch data, we get a weather forecast, 133 freezing, and so on. And if you come back here, notice it doesn't change. It still says 133 and freezing. And the dates are from 2018. And that's because it's just pulling from a JSON file in the application. There's not actually anything, I believe it's in www.root sample data weather.json. So there's the weather it's pulling from. That's not the best. We want to actually call from an API. So what we're going to do is we're going to call our demo API instead. But we're going to use NSwag, which is a tool that works upon Swagger to auto-generate for us a client. This is going to probably blow your mind a little bit. We're going to step through it. We're not going to go deep into NSwag today, but I do want to show you why it's important to have OpenAPI in our API projects because of what it allows for on the client side. All right, so step one, right-click on Connected Services. This may be something you've missed in the past, maybe you haven't used. It's not something you necessarily use often, but there's some really cool stuff in here. So add Connected Services. This is where you add service dependencies, including OpenAPI or gRPC. So you want to talk to gRPC from Blazor WebAssembly, not a problem. You would do it right here. But let's hit add under this middle section where it also says OpenAPI. We're going to choose OpenAPI. Remember that OpenAPI and Swagger is OpenAPI, therefore we already have an OpenAPI. And we're going to choose a file, a URL, or somewhere else. Actually, no, that's the only two places we have options though. So we're going to choose a file. Now you can choose the URL and point to an existing API if you want to. But in our case, we have the URL down or the file downloaded. So let's hit browse and notice we're in the Blazor WASM demo folder. There's our swagger.json. That's the auto-generated swagger.json we just downloaded from our API. Double click it. Namespace for the generated code, we're going to leave it blank, which will use the Blazor Web Assembly or Blazor WASM demo namespace, and we'll hit finish. Now, this is going to bring in NSwag, the client, and API description client, and it's going to use newtonsoft.json, and that's about it. So now we have our client in place. Let's hit save. But it seems like nothing has changed. I want you to see there's a button up here. Let's zoom in here. There's a button at the very top that says show all files. And if we look in the OBJ folder, this gets recreated. So if you ever have a problem where you think maybe it's using old code or an old build, you can delete the OBJ and bin folder and it will recreate it the next time you build your application. But in here, we have Swagger client. Double click that. Let's zoom out. This is an auto-generated client that was built using NSwag. And it was built off of our swagger.json file. This is all set up to talk to our entire API. Let me show you how to use this. Notice it says Swagger client is the class name. So we can go over to our pages. Let's go to fetch data. This is where we normally load our sample data / weather.json file. We're not going to do that. Instead, we're going to get information from our API. Now our API, let's go to our API real quick and grab under properties. The launch settings.json. The SSL port for IIS is going to be 44316. I copy that. And then in here, in this forecast, I'm going to change this. Actually, let's go one level higher first and say Swagger client. Notice it's found it. Let's call it client equals new. This is the new syntax here. I don't have to put new Swagger client. I can say new. And then let's say, get rid of string here. HTTPS / localhost that port number I just specified or found. And then we'll pass in HTTP like so. Now what did I just do? Well, I create a new Swagger client instance. That Swagger client is the auto-generated client for our API. And I said you have to pass in two pieces of information. First of all, the base URL for your API. This is where you're talking to. Remember that this is just the client side. You still have to have your API running. And so where is it running? Well, in this case, it's on localhost / 44316. We also have to pass in our HTTP client. But I pass in HTTP. Where is that? At the very top here we have inject HTTP client, and we named it HTTP. This is the standard thing to do in Blazor Web Assembly. It's actually using the HTTP client factory to create instances and dispose of them properly and make sure we don't have a problem with our connections to HTTP, and we don't have any problems with keeping things open too long or too short and those kind of things. So that's kind of the quick way is just to pass those two pieces of information, and now we have this thing called client. So down here we can get rid of this call for forecasts and say client.get async, and it says I can't even find that. There we go. Weather forecast async. So it's going to get the weather forecast asynchronously. Now the weather forecast async returns an I collection of Blazor WASM demo.weather forecast. Not the same thing as what we have up here. So first of all, it's an I collection of Blazor Web Assembly demo.weather forecasts. We can't do a too short date string up here. It comes through as a date time offset, which that's a translation issue, and it's something that you can tweak with NSwag. I just haven't done it because I wanted to keep it as simple as possible. But this is just to kind of demo what you can do with NSwag. So I'm saying that's the base URL. That's my HTTP client. Instantiate this client object, and then just say client.weatherForecastAsync. That's our get command. That returns a set of weather forecasts, which we then display up here. Now, I didn't have to change any code up here besides that get short date, because of the fact that the structure is pretty much the same thing, because they use the same demo code all over. But now, instead of pulling from, in our Blazor Web Assembly, instead of pulling from this sample data weather.json, we're going to pull from our API instead. Now, there is one tweak to make. In program.cs, the HTTP client, by default, they add on this, it's the base address of the same Blazor Web Assembly project. So it's saying, hey, here's a shortcut. Use the base address from where we're running as the starter place for the address. Well, we're calling a different API, so we don't want to do that. So let's just not put a base address in. We can pass in the address every single time. So with that change, let's do this. Right-click on your solution, set startup projects, multiple projects. We're going to choose our demo API to start, move that up one, and then our Blazor Web Assembly to start without debugging. So we have two projects opening. The API opens first, and then the Blazor Web Assembly. Hit OK. Run this. I have noticed some quirkiness with loading two projects at the same time. So note that can cause a little bit of issues sometimes, but it should launch. So there's our weather forecast. And if we open this up and try it out and execute, it does execute. But it opens a separate window. It's a little weird, but here's my Blazor Web Assembly. Fetch data, and it says unhandled error has occurred. Aha. If you hit, well, first of all, notice that you can hit reload. It'll try again. Still an unhandled error. Hit F12. Enter console. You'll see what the error is. Now the error here is access to fetch at this from this origin has been blocked by CORS policy. No access control allow origin header is present on the requested resources. This is a CORS issue, a cross-origin resource sharing? I forget. So many acronyms in software development. But basically what this says is you are on one URL, the API is, and your Blazor Web Assembly project is on a different URL. And I don't have a rule in place in the API that says that's okay. And so since you're not on the same URL, I'm going to say, no, you can't talk. We're going to open that up. So we're going to allow more of that. Just note up here, it says Blazor Web Assembly loaded with 8.89 megabytes of resources. First of all, that may freak you right out because it seems like it's a ton of resources. This is in development mode, not production mode. There's a big difference here. Published applications will be significantly smaller. They kind of point that out there. So a lot of stuff going on here. Honestly, yes, that's a big number, but it's not nearly as big as what most production applications are. But that's just beside the point. We'll talk about that later in the Blazor video, which comes out in a couple more videos after this one. So anywho, that F12 showed us the error. And so you got a CORS error. So, okay, we're going to close that down. What we're going to do is we'll hit stop, and we're going to go back to our API, go back to startup, and we're going to make some modifications here. And at this point, it's kind of bonus coverage we're doing here to show off how to enable CORS for certain websites. But I want to do this, but I want to show you that yes, this would work. And then we'll actually even show a desktop client or a console application that's also using this this generated client, just to show you off the different ways we can do this. So let's start off with inside of configure services. We're going to say services dot add cores. And we'll say options. No, not options builder. Options, that's the name I want to use. Arrow, curly braces, options dot add policy. And the name of the policy will be, I don't know, WASM policy. Sure. Doesn't really matter. Comma. Let's get our cursor out of here. Builder. Arrow. A lot of stuff going on here. And then in here, builder.withOrigins. This is where we specify which URLs can have access to our application. Well, let's go and look at what Blazor Web Assembly under Properties, Launch Settings, 44314. So we're going to say HTTPS localhost colon 44314. That gets access. But you know what? If you were to launch, let's go to the next line here. If you were to launch with Kestrel instead, you'd have HTTPS localhost colon 5001. That's a standard port. And let's call that good. And then what we're going to do is say dot with methods, and we'll just say just get for now. So what does that do for us? Let's put our semicolons all the way down. What does this do for us? So we're saying is I want to create a new policy for course. You can create more policies if you want, but we're creating just one policy, and that policy is that we're going to allow calls that have an origin of this URL or this URL, but they can only make GET calls. So if it's a GET call from those two locations, cool, no problem. If you want to have more than that, you can say post, delete, and so on. It's up to you if you want to add extras in, but that allows you to kind of dial things in. Cores is not security, and really, in a lot of ways, it's a pain in the butt, but it is what it is. So that's how you would configure the policy, but now we need to apply the policy. So let's scroll down under the configure method. After routing, app.useRouting, before authorization, say app.useCores. And I even forget what our policy name is, but that policy name is WASM policy. So use cores and use that policy. So that's all there is for cores. We hit run, and now it should be that our site has access to that API. Now the API has started. Let's go to fetch data, and now we have data. Notice it says warm with a temperature of 9 here. We go back to this. Now the temperature is 46 and it's cool. So it's fetching from our API every time we come to this page now. So just using that generated client, we were able to very, very quickly talk to our API. There wasn't a lot of setup. There wasn't a lot of overhead. Now, I have a love-hate relationship with generated code. And I am perfectly fine with you saying I never want to use NSwag ever. That's cool. Because when you generate code, it's kind of like Entity Framework. Entity Framework generates a database for you. And you say, man, that's great. I don't have to do the work. That's true. But when it breaks, it's on you to fix it. Well, in the same way, if this generated code breaks, it's on you to fix it. So you got to figure out, you turn on the view files here and go to a Swagger client. You got to figure out what's going on in this file, why it's not working, what's going on, what's happening, and so on. Notice this file is 266 lines long. for one endpoint. Now, it won't scale at that, so 2 endpoints won't make it 500 lines long, but that's still a lot of lines of code. You have to be able to at least know how to debug it in order to figure out what's going on. You, in theory, could come in here and make changes, but remember this is generated. Because it's generated, it can get regenerated and overwrite your code. So you could take this code and just put it right into your code and not have it generate anymore and just make your modifications. For example, there can be some conversion types like right here, where we have the NewtonSoft JSON property. Notice it's capital D in C#, but lowercase d for the JSON property. Really cool stuff right there. And there's a lot of stuff you can learn in here as well. You can learn about how these different things work. But in general, if you're comfortable maintaining this file, then this is a great option because it saves some work. But if you're not comfortable with understanding what's going on, then maybe you don't want to do that. Maybe you want to do the work yourself. I'm not advocating that you necessarily have to use NSwag. I'm not even saying that you should use NSwag. I'm saying it's an option for you to at least consider. And that's one of the reasons why I think that OpenAPI is such a big deal inside of API, because that allows those generators to work. And those generators aren't just for C#. You can have generators for JavaScript, for C++, for Objective-C. There's a lot of different generators out there that will create clients to talk to your API based upon that OpenAPI standard. Really cool stuff. Now, just to kind of drive this point home, let's right-click on the solution and add one more project. We'll do a lot quicker in this project, console app.NET Core. And we'll call this our console demo. And in here, what we're going to do, I'm not going to take out the namespace class and method name, make it a top level call. I could, and I guess it's kind of a possibility that would be useful, but just note that that's definitely possible. Real quick side note here, I've gotten some pushback on why top level calls are important. People really want to see console demo, program, and main in their code. I get that, except for the fact that this is a special method. This special method can't really be called anywhere else. So why does it have a namespace? Why does it have a class name? Why does it have a name itself? It can't be called anywhere else. So even though this looks like a normal method, it's not a normal method. So why are we treating it like a normal method? So just my thoughts there. Getting rid of all this code and it's starting from the very top seems logical to me. But you don't have to use it. Okay, inside of our code, in our console demo, let's grab our, in Blazor Web Assembly. There we go. Let's not show those anymore. And let's grab our swagger.json and drag it into console demo, which makes a copy of it. So this is the same copy we've used from our API. Well, now we can do is under our console demo, we can say add connected service, add OpenAPI file, that JSON file, hit finish. It adds the stuff it needs. We hit close. We hit save. And now in here, we can say Swagger client client equals new. We need the URL for our API. That'd be, HTTPS, localhost, and I believe it was 44316. Let's see what my memory was. And then for HTTP client, I'm going to cheat here. I'm going to cheat real bad. Just for sake of time, I'm going to say new client. In fact, let's be more clear there. I could just use new, but I'm going to use new HTTP client because of the fact that it's not being, I don't see what the new is. I don't see that it's HTTP client. Now I do see in my cheat here, but that's okay. Oh, and it's saying here that new is not available for C#8. That's because I haven't changed. Right click on your console demo properties, change to .NET Core 5. There we go. So I have now called that API, and I can say, or I've got the connection to the API. Now I can say, let's just say var records equals client dot, and the call was weather forecast async. I can say for each var r in records console write line string interpolation, which is our $. That allows us to put our curly brace in here and say r dot, I believe it is date space or colon space r dot summary. And records here is saying, oops, haha. It's saying you can't do that because it's a task, not a list. That's why I'm not getting IntelliSense down here. Whenever you don't get IntelliSense, it's probably your problem, not the code's problem. I have to say await here. But that raises a problem because main is not asynchronous. Well, I can say async task. Control dot to add the using statement for system.threading.http or .tasks. And now we're good to go. Let's run our application. We have to add this to our multi-start. Set startup projects. Let's start our console app without debugging, but we'll move that to the bottom of the list. That way it starts after the API starts. All right, the API where it popped up the other screen. There we go. There's our dates and balmy, mild, hot, freezing, and scorching. So our weather's gonna fluctuate pretty rapidly. So there is in what, 2 lines of code? All right, so we have, 2 lines of code. I was able to set up the client and talk to it. Now, if you want top level call, there we go. Now, notice you have to say actually put a user statement up here. Using console demo. And the reason why is we don't have a namespace. Since it's not a namespace at all, you have to have the namespace of your root project if you're gonna call something else on the root. So, but now we've cut that down to 13 lines of code to talk to an API and get all the data out of it and display it. Now, I did say this is a shortcut up here. I want to spend a couple more seconds here, just to let you know, this is not the way to create an HTTP client. This is a quick and dirty way, but it's definitely not something you want to have in production. Because this could bankrupt your system of available connections to the internet, you don't want to do that. You want to use the HTTP client factory, which would mean setting up the, ideally dependency injection, and then using the dependency injection systems for HTTP client. I go over setting up a better console in a different video on this channel. And so I'd encourage you to check that out. Also, if you want to learn more about Swagger, I would encourage you to check out the Timco Retail Manager series, where we go kind of in more depth and actually use it in the real world type setting. Now, we don't generate our clients, but we do use it to test our API and try different things out. So those are the changes in API. They seem minor, just adding Swagger or OpenAPI and making sure that it starts on that Swagger page when you hit F5. Those are the big changes in API besides the behind the scenes speed improvements. There's a lot of performance improvements in .NET 5. Every version of .NET Core has major speed improvements. So if nothing else, just upgrading a .NET Core will give you better speed in your application. How much? Depends on your application and what you're using, but it will perform better. So, but those are two what seem to be minor tweaks, but at the same time, they enable us by default to create this type of system where we can have auto-generated clients. Really cool stuff. I think it's really important. And I think that it's something you should at least think about implementing in your APIs. I also want you to at least check out NSwag, try it out with a generated client, see how it works, see if you understand the code, and maybe read that code as well, because that will increase your knowledge around calling APIs. So with that, I want to finish here for this video. In the next video, we're going to talk about something that's not necessarily new, but it's something that I think is important to talk about in this whole .NET 5 era, and that's the concept of HTTP REPL. And so we'll talk about that and how to debug much more easily our APIs using HTTP REPL. So that'll be the next video. But for now, thanks for watching. And as always, I am Tim Corey.